Ascending tracts. Which ascending tracts do you remember in spinal cord? Anterior. Spinal cord, that is medulla, here it is pons, midbrain, thalamus, internal capsule, and cortex of brain. First tract, that is conductive tracts of motor analyzer. Motor analyzer, it's conduct conscious proprioceptive sensitivity. If it is motor analyzer, receptors in apparatus of movement, that is muscles, ligaments, capsules of joints, and from receptors sensory impulses pass to the first neuron. Where is first neuron? In spinal ganglion. For all ascending tracts, today we will speak about 5 ascending tracts. First neuron always in spinal ganglion. And from this first neuron, axon of this first neuron, goes to posterior funiculus, and here it is, we have fasciculus gracilis and fasciculus cuneatus. And this fascicles goes to medulla, and in medulla we have second neuron, that is nucleus gracilis and nucleus cuneatus, that is second neuron. From second neuron start tractus bulba thalamicus. It goes to opposite side, makes decussatio lemniscorum, and continues into pons, that is trapezoid body, and above of trapezoid body, that is lemniscus medialis. Then lemniscus medialis continues into midbrain. Here it is the same lemniscus medialis. Then third neuron, that is lateral nuclei of thalamus, third neuron. And from this lateral nuclei, tractus thalama corticalis, it passes through posterior crus of internal capsule, goes to brain cortex, and finish where is cortical center of motor analyzer in gyrus praecentralis. That is why name of this tract, tractus ganglio bulbo thalama corticalis. You should write where is receptor, first neuron, spinal ganglion, second nucleus gracilis and cuneatus, third neuron, lateral nuclei of thalamus, and cortical center in gyrus praecentralis and lobulus paracentralis. The same you should write number 1, that is fasciculus gracilis, number 2 fasciculus cuneatus, number 3 decussatio lemniscorum, number 4 tractus bulbothalamicus, number 5 lemniscus medialis, here it is the same lemniscus medialis, and number 6 tractus thalama corticalis. And you should write that it's conduct conscious proprioceptive sensitivity. That is first diagram. Then skin analyzer, and now we will speak about temperature and pain. That is why receptors in skin. First neuron, we already said that always were in spinal ganglion, And what is the second neuron for temperature and pain?
Gelatinous substance.
No? Nuclei propria. Good, nuclei propria. From here, axons goes to opposite side through commissura alba, and in lateral funiculus makes tractus spina thalamicus lateralis. In dorsal part it conducts feeling of temperature, in ventral feeling of pain. Spina thalamicus lateralis goes to thalamus. Here it is third neuron in lateral nuclei, then tractus thalamicorticalis and cortical center in gyrus post centralis. What you need to write first, that is commissura alba. Number 2, spina thalamicus lateralis. Here it is the same, spina thalamicus lateralis. In pons, that is lemniscus medialis. Here it is also lemniscus medialis, and here it is number 4, tractus thalamicorticalis. Clear? That is second diagram. Next. And what is the name of all of this tract? Tractus, it was ganglio what? Bulbo thalamicorticalis, and here it is ganglio spina thalamicorticalis. Now conductive tracts of tactile sensitivity. That is also skin analyzer. It starts from receptors in skin. First neuron that is pseudounipolar neuron in spinal ganglion, and second neuron substantial synosa. It is second A neuron. Axon goes to opposite side and makes tractus spina thalamicus anterior, and this tract goes to lateral nuclei of thalamus, and tractus thalamicorticalis goes to brain cortex, that is gyrus postcentralis and lobulus parietalis superior. What is here? Number 1, commissura alba. Number 2, spina thalamicus anterior. Here it is the same, spina thalamicus anterior. Number 3, lemniscus medialis, the same. Number 4, tractus thalamicorticalis. But tactile sensitivity, the same, include feeling of stereognosis, and stereognosis conduct fasciculus gracilis and fasciculus cuneatus, and in this case second neuron, that is nucleus gracilis, that is why it is second B neuron, and this tract, tractus bulbothalamicus, and then the same goes to lemniscus medialis, lateral nuclei of thalamus, tractus thalamicorticalis, and gyrus postcentralis and lobulus parietalis superior. That is why this tract, tactile sensitivity, consists of tractus ganglio spina thalamicorticalis and tractus ganglio bulba thalamicorticalis. And it is number 5, that is decussatio lemniscorum, and number 6, tractus bulba thalamicus. Clear it is. And last two tracts, they are conductive tracts of unconscious proprioceptive sensitivity. They goes to cerebellum. Which tracts do you know which goes to cerebellum? Spina, from spinal cord, spina, anterior and posterior. That is spinal cord, and pons and medulla I will draw this way. That is sagittal section, that is pons and medulla. Here it is. That is medulla oblongata, that is pons. Here it is superior peduncles of cerebellum. Here it is inferior peduncles, and that is cortex of cerebellum. Clear it is? Sagittal section of medulla and pons. Receptors in apparatus of movement. First neuron in spinal ganglion, and second neuron nucleus thoracicus. That is second neuron. Axons of nucleus thoracicus goes to the same side. Here it is tractus spinocerebellaris posterior, and this tract goes to medulla and through inferior peduncles goes to cortex of cerebellum. First neuron here, second nucleus thoracicus, that cortex of vermis, for example. And here it is number 1, that is tractus spinocerebellaris posterior, and number 2 pedunculate cerebellaris inferior. And last diagram, that is tractus spinocerebellaris anterior. The same pons, medulla, inferior peduncles, superior cerebellum, and opposite side, pons, medulla, inferior, superior peduncles, and cortex of cerebellum. From receptors in apparatus of movement, first neuron in spinal ganglion, and second neuron nucleus intermedio medialis. Axons of the second neuron goes to opposite side, makes here it is tractus spinocerebellaris anterior, goes to medulla, pons, and at the level of isthmus rhombencephaly, it goes to opposite side one again through velum medullaris superior, and through superior peduncles goes to cortex of cerebellum. That is cortex of vermis. It is number 1 commissura alba, number 2 tractus spinocerebellaris anterior, number 3 velum medullare superior, and number 4 pedunculate cerebellaris superior. Both of them conduct unconscious proprioceptor sensitivity. 5 diagrams next time. Ascending tracts, only ascending. That is all.